Hi, boys and girls. It's Miss Bissell. We're getting ready to go over your test that you took on representing and interpreting data. You boys and girls should have your math work journal where you have worked out these problems. You've definitely written down your answer choice for the 15 problems and shown some work probably. So we need to look at that while we go over the test. All right, so question number 1. And again, I have the paper version. You guys have this under SchoolNet. If you need to open it back up and look at the test, if your parents want to see the actual test, that's where all your tests are for 5th grade math this year. All right, a town recorded its population every 10 years. The results are shown in the graph. So we always talk about before we go and start answering questions, we analyze what's on the actual graph. So the title is Town Population. Along the x-axis, we see the years from 1900 to 1980, 1990, all the way over to 2000. Each of these vertical lines goes up by 10 years. On the y-axis, we have the population in thousands. So we've got to be careful with that. 45 does not mean 45 people. It means 45,000 people. All right, so the question is, what was the town population in the year 1960? So we locate 1960 along the x-axis. We follow it up. Here's our data point. We follow it over and see a 20 here. So be careful. That's not 20 people. It's 20,000 people. And a couple of you picked the decoy answer A just because you weren't paying attention to that. All right, let's look at number 2. Number 2, Eat-A-Lot Cereal Company made a graph to show how many boxes of cereal it sold between 1996 and 2000. So here are the years, the 5-year period, and here are the increments. We can see we've got some missing increments between 0 and 100,000. We see the little cut symbol here. So I see we're going up in increments of 250, all right, on every one of those horizontal lines. All right, between what 2 years did Eat-A-Lot Cereal Company have the greatest increase in sales? Now, this one is an example of where we really have to understand line slope. All right, so increase is where we go from a data point on the left to a data point on the right, and we're going upwards. All right, the steeper and longer the line, the greater the increase. All right, we talked about that. We had a whole lesson on this. So when I look at 96 to 97, I'm looking at this line right here. So one thing that I can use kind of as a visual helper are these two horizontal lines. So these represent a difference of 250 boxes of cereal. Okay, so we aren't even at a whole 250. We haven't gone between two increments. So that's not very steep. That's not a big increase. 97 to 98. 97 to 98. Take a look at this. It's long and it's steep, and it goes past one complete set of numbers. So right here's 250 in between here of cereal boxes. All right. It actually looks like it's about halfway. So this one's long and steep. I'm thinking it's this one. Definitely can't be A. B is definitely more sales than A. C, from 98 to 99. All right. I can tell you it's not going to be C for the same reason that it's not A. It doesn't, the data points, there's not even an increase of 250 boxes, okay? It doesn't span across two of the different increment markings, so it can't be C. D, it's steep, all right? The question is it as steep and as long as between 97 and 98? And when I look at it, it goes past one set of increment marks and barely into another. So it is not as long and steep as 97 to 98. So we're going to pick B as that choice. All right. Number 3. The graph shows the number of students who attended the football game last fall. So here are the 5 different games being represented. Here are 0 students up to 300. I noticed that they don't have the vertical lines, but we can picture where they would be. I want to know which table matches the data correctly. Oh, cuts off a little bit here. So game number 1. So what they're doing, and it's kind of cut off here, but you can see for each of your answer choices that you have on your computer screen, it's giving you the attendance. So I think the best thing to do actually is to just on my sheet of paper, and I don't have my journal with me, so I'm just going to put it on a little sticky note. I'm going to put what is being depicted on the graph for each game. So for game 1, when I look at it, the data point, there are 150 students. All right. The second game, when I look at it, it's between 100 and 150. It looks like it's halfway, so that's going to put us at 125 students. The third game, we follow it up. It's halfway between 150 and 200, so we're going to write 175. Game 4, we have 150 students. And the last game, we have 200 students. So now that I have this information here, it's almost like I have my own little table. All right. It's almost like my own little table. So I can take a look at this one. So game number 1 in answer choice A, 150. That's correct. Game 2, 125 is what we have, but they're telling me 275. So if that is not the correct number of people or students attending the game, then it can't be answer choice A. So let's take my information since I'm on paper, and let's go ahead and look at answer choice B. So 150 should be 125 students at game 2. It is not, so it can't be B. All right, let's look at C. 150 are at game 1, 200 at game 2. Uh-oh, it can't be C. All right, I'm hoping it's D. Game 1, 150 people. Game 2, 125. Game 3, 175. Game 4, 150. Game 5, 200. So the information that came out of this T-chart, basically, is what was depicted on this graph. So we kind of work backwards, right? All right. So our correct answer is D. All right. Let's keep on moving. We're going to look at problem number 4. The chart below shows 6 months of a company's sales figures. All right, so we have the months April through September. And again, my sales, this is not $10 and $20. It's sales in thousands of dollars. So 50 means $50,000. All right. Between what 2 months did the sales decrease the most? So decrease, we would be going from one data point to the other in a downward line, okay? So this one doesn't have any X or Y markings as far as our lines. Doesn't look like graph paper behind there, so we just have to be careful when we're working and stay straight. So between July to August, let's look at what's happening. July to August. Well, wait a minute. That's not even a decrease. That's an increase. All right. May to June. All right. May to June is a decrease. So that's a possibility. April to May. That's an increase from April to May. So it can't be C. And August to September. That's a decrease. So it's either going to be A or D for our answer choice. So let's go back and let's talk about it. I can clearly see this without doing computation work, just like I could in number 2. I can clearly tell you which months had the greatest decrease, and it's going to be from August to September. I know that it's because it's a much longer line, a much steeper line. All right, this one's more at this angle, where here it comes down a little more. So my answer is going to be D. And that's strictly based on me understanding how to read line, slope, and length for increases, decreases, and data that stays the same. All right, number 5. The graph below shows the number of runs scored by the Spiders baseball team during each month of the baseball season. So we're going from April to September, and we go from 0 runs to 20. So the question is, how many more runs, how many more is indicative that I'm going to be doing some subtraction. How many more runs did the Spiders score in August than in May? So let's look at what August was. We follow it up. Here's our data point. We follow it over. There were 18 runs in August. In May, we follow it up and follow it over. There were 10. So there were 8 more runs in August than in May. So my answer choice is D. All right, moving right along to number 7. The number of kindergartners entering Polk Elementary has increased for 4 years as shown on the graph. If this trend continues, what is a reasonable prediction of the number of students that will enter kindergarten in year 5? So I'm looking at this trend. Let's go ahead and connect the points. So we go from year 1, looks like about 72 students. Year 2 looks like 78-ish. Year 3, I'm going to guess about 84 students. Year 4, it looks like, well, it is 90 students. So they're asking if it could be 85 students if the trend continues. Well, if it dropped down to 85, then that would be a decrease. And the trend is it's increasing. Not exactly the same amount, but on average around the same. So I'm going to say it is absolutely not going to be A, because then that would show a decrease. B has us at 90 students, but the problem with that is there's no years on this trend where they stay the same. So the enrollment changes, a little bit more students entering kindergarten each year, so it can't be 90. So our next choice is 91 or 96. So if year 5 we were at 91, it would look something like that, and 96 would look something like this. And 91 would almost be evened out. It would almost be, one more student versus a line that would look like this. So again, understanding trends and lines, this one's going to be my better choice. So 96 is going to be what I'm going to predict. All right. It's about 5 students every, give or take 1 or 2, every year that are increasing in enrollment for kindergarten. All right, number 7. The height of a boy from age 3 to age 8 is shown on the line graph. So here are his ages. All right, and here's his height in inches. So we're going to go from 36 to 52 inches. Looks like every one of these horizontal lines goes up by 2 inches. The question is, how many inches did the boy grow between 5 and 8 years? So when he was 5 years old, this is the data point for 5. If we follow it over, he's at 42 inches. All right. If we look at age 8, we follow it up. Here's the data point. Follow it over. He's 52 inches tall. So to find out how much he grew between those 2 years, we would subtract. So if you think about it, if we go to his height at age 5, which was 42 inches, and we add those 10 inches, we should be at that 52 inches at age 8. So the answer is C. All right, number 9. A cashier at a school recorded the number of notebooks sold over a 6-week period. Which line graph correctly displays this information? So we have the 6 weeks and the number of notebooks. All right, so here's our T-chart with our information. So we need to find a graph that has the same information. All right, this is going to be tricky. So I'm going to just jot this down real quick. Week 1 through 6. Just going to jot it down because I'm going to have to flip over So what we know are that the data points are going to have to match exactly, okay? So this is what I mean. I don't have a computer screen to scroll down. I've got everything on paper. So each of the 6 data points need to be correctly plotted or we don't have the solution. So let's check A. So we start at 25. We go down to a little less than 10. All right, looking good. And week 3, we should be at 22. Well, 22 would be about here. So it can't be A. All right, let's work on B. We start at 25. Well, week 1 is at 20, so we can go ahead and eliminate B. All right, the third choice. All right, we start at 25, and I see this data point is above 25. All right, if I'm just thinking, well, maybe it's just off a little bit, let me look at what the sales are in week 2. Week 2 is definitely more than 10 notebooks, and they only sold 9, so it can't be C. All right, we're back to hoping that D is correct. So week 1, 25. Week 2, 9. Week 3, 22, looking good. Week 4 should be 17, yes. Week 5 should be 11, and week 6 should be 26. So there it is. Definitely answer choice D. All right. Number 9. Which graph can be used to demonstrate Tony's fluctuating scores at darts? So the word is fluctuating. So fluctuating means something changes. It goes up and down, doesn't stay the same. All right. So A would not show any fluctuation in Tony's scores. As a matter of fact, Tony's increasing about the same amount each week. Answer choice B, that graph doesn't work because the scores don't fluctuate. They are exactly the same each week. All right. Graph C, they decrease from week to week at a constant rate. So the only one that I see that has fluctuating data where it goes up from 1 to, or up from 2 to 4, down to 2, up to 3, and up to 4 for the score is answer choice D. All right. Number 10. During an experiment, students counted the number of bubbles given off by plants every 2 minutes during a 10-minute period. The results are graphed below. All right, so here's the time in minutes, 0 to 10 minutes. Here we are in the number of bubbles from 0 to 13. All right, at which 2 times were the same number of bubbles given off? All right, so we're looking for a no change in data between 2 different points. So I hope everybody right off the bat saw that there's no change of data between 6 and 8 minutes. All right, we have an increase between 0 and 2, 2 and 4, 4 and 6. It stays the same from 6 to 8, and from 8 to 10 minutes, there is a decrease in the number of bubbles given off. So we are looking at between 6 and 8 minutes. So the answer is C. And again, we're looking for not a change in data. No change in data, a constant. All right, number 11. The graph shows information about rainfall in the town of Oak Grove. All right, so years 1996 to 2005, these are the inches of rain from 0 to 50. According to the graph, which statement is true about the yearly rainfall totals? All right, A, the rainfall total decreased every year from 96 until 2001. Well, I know that's not true because 96 to 97 it increased. And from 2000 to 2001 it increased. We see those lines doing this, right? That's increase. So it can't be A. B, the rainfall total increased only 1 time in the year shown. Well, I know that that can't be true. Here's an increase, here's an increase, and here's an increase. So that's 3 times. All right, so can't be B. C, the rainfall total was never less than 25 inches for the year shown. So here is the 20, let's see, 20 and 30. So 25 is right here. Well, I can already tell you that that's false because it says that it never went less than 25 inches, and it did right here. All right, let's check D. The rainfall total was never greater than 50 inches for the year shown. So here's 50. So there's that 50 line, and that is true. There's not any year where the rain total went above 50 inches. So we sure do have a lot of D answers on this test. All right, number 12. The graph below shows the number of students who graduated from 6th grade in a certain school year. So here we go from 91 to 97. All right, here we go from 30 students to 60. All right, what is the total number of students who have graduated from 6th grade from 1991 to 1997? Helpful information. 52 students graduated in 93 and 47 graduated in 96. Maybe I'm getting that tip because it's hard to read. So I need to find the total number. So I'm going to just go ahead and do 91, 92, 93, 94, 95, 96, 97. I'm going to pick up this data. I'm going to put it in a T-chart. You know I love T-charts to organize my data. All right, so this is the year, and this is the number of students. So in 91, follow it up. That data point is on the 40. All right, 1992, I follow it up. That data point is 45. 1993, I follow it up, and I'm not sure, but I had some information here under the tip that said 52 students graduated in 93, so that's helpful. In 1994, 45 students. In 1995, 55 students. 1996, that's another one that I can't 100% read, but it told me that 47 students graduated in 1996. So thank you for the tip. And then in 1997, we're at 55 students. All right, so I do need to add all these up, so I need to be careful with that. So 5, 6, 7, plus 10 more, 17, plus 7 more, 24, plus 5 more is 29. All right, I would definitely count things twice if I were you. I know 4 and 4 is 8, plus 2 more is 10, plus 5 is 15, plus 4 is 19, plus 5 is 24, plus 4 more is 28, plus 5 more is 33. Now, if I were not working this right now, if I was taking the test, I would definitely add those twice to make sure that I have 339 again. The answer is A. All right, number 13. Which question requires gathering numerical data? So numerical data, our answers when people would answer our survey question would be in numbers. So what are my favorite TV shows? Well, I like the oldies like Little House on the Prairie. I like to watch different shows, but they have names. So that's not numerical data. All right. How many goldfish are in the pet store? Well, I'd have to go count the number of goldfish. So I'm thinking my answer is going to be B. C. What breeds of dogs are in this dog show? Well, breeds of dogs would be like Cocker Spaniels, German Shepherds, Golden Retrievers. Those aren't numbers. Those are names. So it's not going to be C. Number D, what are the 7 tallest mountains in the world? So, we would be naming mountains like Mount Everest, not counting them. So, our only answer that yields numerical data is how many goldfish are in the pet store. All right. Number 14, which question requires gathering data that changes over time? We would plot the results on a line graph to show those changes over time. So, A, how much time did you spend on science homework last night? All right. So, last night would be one amount of time. So, maybe you spent 25 minutes. All right. That doesn't represent data that changes over time. That's just a numerical answer. What is your favorite holiday? Well, maybe you love Christmas, or maybe you love Halloween, or maybe you love Valentine's Day. Well, that's categorical data. That's not even data that changes over time. How many pizzas did Pizza Hut sell each month for 1 year? Well, how many months are in a year? There's 12 months in a year, and the pizza sales, I'm sure, differ from month to month. So I could see a graph similar to this line graph where we have each of the 12 months and then the number of pizzas sold, and I could see the data changing. So I'm going to go with this as my choice so far. How tall are you? Well, right now I'm 5'4". That's not data that changes. It wants to know right now. Yes, it is a number answer, but it is not going to be data that changes over time because it's very similar to question A. It just wants to know right now. So the answer is C, where we would have those 12 data points for the number of pizzas sold each month. All right, number 15, our last question. Which question requires gathering categorical data? So that these are questions that when we present them to someone, their answers could be grouped in different categories. All right. They're not going to be giving us numbers that could be measured in any way, shape, or form. So if I asked how many students are in my school, that's a number. To get that answer, we have to count them. All right. So it can't be A. B, how many cars can park in the parking lot? Well, we'd have to go out and count the number of parking spaces. So again, that's not giving us, categorical answers or answers of information that be categorized. What species of carnivorous fish are in the ocean? So somebody would be giving me names of the carnivorous fish in the ocean. And it's that one so far. What is the amount of hamburgers eaten in one day? Well, we'd have to count them. So that would be numerical data. So, yes, our answer was C. What species of carnivorous fish are in the ocean? All right, so boys and girls, you have gone over each item with me on your test. You had your answers recorded in your math work journal as I require for every test so that we can have a meaningful review of the test items. So hopefully you can see what you did right and what maybe you need to improve on. All right. Well, that concludes this going over of the test. We will get back at it tomorrow, and we will start tomorrow with adding and subtracting fractions. So I will see you soon. Have a great day.